This video is actually a section of a course. The course name is C Programming for Beginners. This video includes the following lessons. First, variables, concept of variables, declaration, and initialization. Second, variables, basic data types, integer, float, double, char. Third, constants, using the const keyword and hashtag define. Fourth, operators, arithmetic operators, plus, minus, times, over, mod. Fifth, operators, assignment operators, equal, plus equal, minus equal, etc. Sixth, operators, comparison relational operators, less than, greater than, equal to, not equal to, etc. Seventh, operators, logical operators, and or not. Eighth, basic data, input, output, the printf function, formatted output. Ninth, basic data, input, output, the scanf function, user input. 10th, exercises to practice programming thinking skills, no answers. 11th, solving exercises. Don't see this video if you've not tried to solve. Okay, let's get started. We successfully wrapped up section 1 by understanding the skeleton of every C program, the main function, libraries, and statements. But right now, our program is just a structure that performs one simple task, printing hello, world. It can't do anything useful like calculating your taxes or storing your game score. The missing element is data. And in programming, the fundamental tool for handling data is the variable. This lesson marks the start of section 2, fundamental concepts. We will dedicate this video to mastering the definition, declaration, and initialization of variables, the first step in giving your C program the ability to handle information. Welcome to lesson 2.01. This is where the real programming begins. We are going to explore the basic building block of data management, the variable. By the end of this video, you will confidently know how to create a variable in C using 3 simple concepts: concept, declaration, and initialization. First, concept of a variable. What exactly is a variable? Think of a variable as a named storage location in the computer's memory. It's a reserved box or slot where you can store a piece of information, such as a number or a character. The key word is variable, meaning its value can change throughout the execution of your program. If you track a user's score in a game, that score will constantly vary, hence a variable. Second, declaration. Declaration has a strict syntax. First, you must specify the data type, and then you specify the variable name, followed by a semicolon. For example, integer age. Integer is the type of data you plan to store. When a variable is declared, the compiler is told that the variable with the given name and type exists in the program, but no memory is allocated to it yet. Memory is allocated when the variable is defined. When the variable is defined, which also means when the variable is initialized. Third, initialization, the first assignment. The next step is initialization. This is the act of giving a variable its initial value, its very first piece of data. You can do this in 2 ways. Way number 1, separate assignment. You declare the variable first, and then assign a value later. Like this, integer age, followed by age equals 25. The equal sign is the assignment operator. It takes the value on the right and puts it into the variable on the left. Way number 2, combined declaration and initialization. This is the most common practice. You define the type, name, and initial value all on one line. Integer score equals 100. Now you know how to create a variable. However, we have only used the placeholder type in so far. C is very strict about the type of data a variable stores, whether it's a whole number, a decimal number, or a single letter. Click on the next video to continue with lesson 2.02. Variables. Basic data types. Integer, float/double, character. We will dive deep into the fundamental data types you need to know to store any kind of data successfully. In the last lesson, we learned how to declare and initialize a variable, like integer score equals 100. But what happens if your score isn't 100? What if it's 100.5? If you try to do this, your program will either fail or, worse, produce bizarre results. Why? because C is an extremely strict language. A variable declared as an integer, cannot hold a decimal point. A variable designed for a number cannot hold a single letter. If you choose the wrong data type, your program will break. This is the most fundamental concept in C you must master. Welcome to Lesson 2.02. Today, we are mastering the basic data types. These are the essential building blocks for storing any kind of information. We will cover the three most essential types you will use every single day. Integers. Float/double, decimals. Char, characters. Understanding these is the key to storing your data correctly and efficiently. First, integers. First, the one we already know, int. Int stands for integer. It is used to store whole numbers, numbers with no decimal points. They can be positive, negative, or 0. When you use int, you are telling the computer to reserve a specific amount of memory, usually 4 bytes, dedicated only to whole numbers. Second, float and double, floating point numbers. But what about numbers with decimals like 19.99 or 3.14159? For that, C gives us float and double. Float stands for floating point number. This is how C stores numbers with decimal points. So what is double? Double is just a double precision float. It means it takes up more memory, usually 8 bytes instead of 4 for a float, but it can store much larger decimal numbers and is far more precise. It can hold many more digits after the decimal point. Rule of thumb: if you need high precision, like for scientific calculations, always use double. If you are just storing simple data like a price, float is often fine. Third, char, characters. Finally, what about non-numeric data like a single letter or a symbol? For this, we use char. Char stands for character. It is designed to store exactly one single character. And this syntax is crucial. To initialize a char, you must use single quotes, not double quotes. Fourth, the size of operator, how memory differs. How do we know they use different amounts of memory? C gives us a special operator called sizeof. This operator tells us exactly how many bytes a data type reserves. If we write a quick program to print these sizes, we can see the difference. This confirms that double is twice the size of float, and int takes many times the memory of a char. To summarize, int for whole numbers, float and double for decimals, and char for single characters. These variables are powerful because their values can change. But what if you have a value that you never want to change? For example, the value of pi, 3.14159, or the number of days in a week. If you store that in a variable, you might accidentally change it, which would break your program. For that, we need constants. Click on the next video to watch Lesson 2.03, Constants, using the const keyword and hashtag define. In our last lesson, we learned how to create variables using integer, float, and char. Variables are powerful because their values can change. But what if you have a value that you never want to change? Imagine you define pi as 3.14159, and then 500 lines later, you accidentally change its value. Your entire program's calculations would be wrong. In programming, we have a special way to protect these important values. We don't use variables. We use constants. Welcome to Lesson 2.03. Today, we're learning how to create variables that cannot be changed. A constant is a read-only variable. Once you give it a value, it is locked for the entire life of the program. This makes your code safer, you can't break it by accident, and more readable. There are two primary ways to create constants in C, and we will learn both. The modern way, the const keyword. The traditional way, the hashtag define directive. First, why do we need constants? The magic number problem. Let's imagine you are writing code to calculate sales tax. You might write final price equals original price times 1.07. What is 1.07? It's a magic number. If you see this code 6 months later, you might not remember what it is. And if the sales tax changes, you have to hunt through your entire program to find and replace every 1.07. A much better way is to use a constant. Const float sales tax equals 1.07. Final price equals original price times sales tax. Now, your code is readable, and if the tax rate changes, you only have to change it in one place. Second, method 1. The const keyword, modern and preferred. This is the best and most modern way to create a constant. The syntax is simple. Just add the keyword const right before the data type when you declare a variable. Now, this variable is read-only. What happens if you try to change it? The moment you try to compile this code, the compiler will stop you and give you an error. It's protecting your code for you. This is a true variable with a data type and a value, but the compiler just prevents you from modifying it. Third, method 2. The hashtag define directive, traditional. This is the older classic C method. You will see this everywhere in older C code. Hashtag define is a preprocessor directive just like hashtag include. It runs before the code is compiled. The syntax is different. Pay close attention. Hashtag define PI 3.14159. Notice, there is no data type, int, float, no equal sign, and no semicolon at the end. How does it work? Hashtag define is a simple text replacement tool. Before compiling, this compiling is a phase of the 4 phases of the compiling we know. The preprocessor goes through your file, finds every single instance of the word PI, and replaces it with the text 3.14159. Fourth, const versus hashtag define, which one to use? Const is almost always better and safer. Const is a true variable. The compiler knows its data type, like int or float. Hashtag define is just text replacement. It has no understanding of data types, which can sometimes lead to very strange bugs. Rule of thumb: use const whenever you can. Use hashtag define only if you have a specific reason or if you are working with older code. Now you know how to store data that changes, variables, and data that doesn't change, constants. We have all our building blocks. It's finally time to use them to perform calculations. We need to learn how to add, subtract, multiply, and divide these values. Click on the next video to start lesson 2.04. Operators. Arithmetic operators, where we will learn how to use addition, subtraction, multiplication, division, and the modulus operator. So far, we have learned how to store data in variables like x and y, and constants. We have our building blocks. But what now? How do we use them? How do we add them together? How do we find the difference? Right now, our data is just sitting in memory doing nothing. To make our programs useful, we need to perform operations. To do that, we need operators. Operators are the action verbs of the C language. Welcome to lesson 2.04. This is our first of several lessons on operators, and we are starting with the ones you already know from math: arithmetic operators. These are the symbols that perform calculations. We will cover the 5 essential arithmetic operators: plus sign, addition; minus sign, subtraction; asterisk, multiplication; slash, division; percent sign, modulus or remainder. First, the basics: plus. minus, asterisk, addition, subtraction, multiplication. Let's start with the simple ones. Addition, subtraction, and multiplication work exactly as you'd expect. These operations are straightforward and produce the expected results. Second, the trap, division, /, and integer division. Now, let's look at division, /. This is a major trap for new C programmers. If you divide two floating point numbers, float or double, it works normally. Float result equals 10.0/4.0. The result here is 2.5. But what happens if you divide two integers? Because the variables are of type int, C performs integer division. It truncates the result, meaning it cuts off the decimal part completely. So, x divided by y equals 2. Remember, this is a critical concept in C. Third, the remainder operator modulus. If 10 divided by 4 is 2, what happened to the remainder, which is 2? That's where the modulus operator comes in. The modulus operator gives you only the remainder of an integer division. It is highly useful in many programming tasks, such as finding even odd numbers. 10 divided by 3 is 3, with a remainder of 1. So, 10 mod 3 equals 1. 12 divided by 5 is 2, with a remainder of 2. So, 12 mod 5 equals 2. Fourth, operator precedence, order of operations. Finally, C follows the same order of operations or precedence you learned in math, like PEMDAS or BODMAS. The operators asterisk, slash, and percent sign have higher precedence, are calculated first, then plus and minus. Look at this example. Int result equals 5 plus 2 times 3. The program will do 2 times 3 first, which is 6. Then it adds 5. The result is 11. If you want to do the addition first, you must use parentheses to force the order. Int result equals 5 plus 2 times 3. Now the result is 7 times 3, which is 21. Today, we learned how to calculate new values using arithmetic operators. And you may have noticed we keep using the single equal sign to store that result in a variable. But what if you want to add 10 points to an existing score? You might write score equals score plus 10. This is correct, but C gives us a much cleaner, shorter way to write this specific kind of assignment. The single equal sign is actually an operator itself, and it has a whole family of related operators. Click on the next video to watch lesson 2.05. Operators. Assignment operators. Equals, plus equals, minus equals, etc. In the last lesson, we successfully performed calculations using arithmetic operators like addition and division. But every time we calculated a result, we used this symbol to store it, the equals sign. You might think the equals sign means equals like in math, but in C programming, the single equal sign has a totally different meaning and function. It's an operator itself. Welcome to lesson 2.05. Today, we are mastering the assignment operators. The single equal sign is the fundamental assignment operator, but C gives us a whole family of operators that make your code cleaner, shorter, and faster to write. We will cover equals, simple assignment, compound assignment operators, plus equals, minus equals, times equals, over equals, mod equal. Mastering these shortcuts is a sign of clean, professional C code. First, the simple assignment operator. The single equal sign is the most fundamental operator you use every day. But remember, it does not mean is equal to. The assignment operator means Take the value on the right-hand side and store it into the variable on the left-hand side. In this statement, the value 100 is assigned to the variable named score. The rule is strict. The right side is calculated first, and the result is then stored in the single variable on the left side. You can only assign a value to one variable at a time using equal sign. Second, the need for compound assignment. Imagine you have a score and a player earns 10 bonus points. How would you write that using the arithmetic operators from the previous lesson? This code is perfectly correct, but it's redundant. You are typing the variable name, score, twice. Since this pattern is so common, adding to itself, subtracting from itself, C provides shortcuts called compound assignment operators. Third, compound assignment operators. Compound assignment operators combine an arithmetic operator with the assignment operator. They allow you to perform an operation and assign the result back to the original variable, all in one quick step. Let's look at the basic examples. Add 10 to score, then store the new result in score. Subtract 5 from health, then store the new result in health. Multiply price by 2, then store the new result in price. Divide x by 3, then store the new result in x. Calculate the remainder of count divided by 2, then store the remainder in count. Using the compound forms like plus equals and minus equals is faster to type and generally considered better practice because it makes the code's intent instantly clear. I am modifying this variable by adding to it. You now know how to calculate arithmetic operators and how to store those calculations, assignment operators. But what about making decisions? Right now, your code just runs from top to bottom. It cannot ask questions like, is the score greater than 100? Or, is the user logged in? To introduce logic and decision-making, we need operators that compare values. Click on the next video to watch Lesson 2.06. Operators. Comparison, relational, operators, where we will learn how to ask questions and get a simple true or false answer. So far, our C code can calculate using arithmetic operators like plus sign and store data using assignment operators like equal sign, but our program still runs like a recipe. Step 1, then step 2, then step 3 running straight to the end. Cannot make choices. It cannot decide if the user's score is greater than 100, then display a level up message. To introduce logic and enable decision-making, we need operators that can ask questions. We need comparison operators. Welcome to Lesson 2.06. Today, we master comparison operators, also known as relational operators. These operators allow your program to compare two values and determine the relationship between them. The result of every comparison operator is always a simple, binary answer: true, 1, or false, 0. We will cover the 4 most essential comparison operators: less than, greater than, is equal to, is not equal to, first, less than, and greater than. These operators are exactly what you remember from basic math. They check if one value is smaller or larger than another. Let's declare integer a equals 10 and integer b equals 20. Example 1. Less than integer result 1 equals a is less than b. Is 10 less than 20? Yes. In C, the result stored in result 1 will be 1, true. Example 2. Greater than integer result 2 equals b is greater than 30. Is 20 greater than 30? No. The result stored in result 2 will be 0, false. The related operators less than or equal to and greater than or equal to are simply combinations of the basic operators. Second, the critical trap is equal to. This is arguably the most common mistake for new C programmers. To check if two values are equal, we must use two equal signs. This is the comparison operator. Example: integer result 3 equals 10 is equal to 10. Is 10 equal to 10? Yes. Result is 1 true. What happens if you use the wrong one? If you accidentally write if score equals 100, instead of if score is equal to 100, the compiler will not give you an error. Instead, the assignment operator will assign the value 100 to score. In C, any non-zero value is treated as true, so your condition will always evaluate to true, creating a bug that is incredibly difficult to track down. Rule: always use double equals for comparison. Third is not equal to. The opposite of equality is inequality, denoted by the exclamation mark followed by the equal sign. Integer result 4 equals 5 is not equal to 10. Is 5 not equal to 10? Yes. Result is 1 true. Integer result 5 equals 10 is not equal to 10. Is 10 not equal to 10? No. Result is 0, false. Fourth, the output true is 1, false is 0. In C, the results of these comparisons are stored as simple integers. True is always represented by the integer value 1. False is always represented by the integer value 0. In conditional statements, any non-zero value is treated as true. But for comparison operators, the standard true result is 1. You now know how to ask simple questions. Is A greater than B? Or is C equal to D? But what if you need to ask a compound question? Like, is the score greater than 100 and is the game still running? To combine or negate multiple simple questions into complex logic, we need the final set of operators, logical operators. Click on the next video to watch lesson 2.07. Operators, logical operators, where we will learn how to use and not to build complex decision structures. In the last lesson, we learned how to ask a single, simple question. We can check if score is greater than 100 and get a result: 1, true, or 0, false. But in the real world, logic is rarely that simple. We don't just ask one question. We ask compound questions like, to open this door, does the player have the key and is the power on? To win the game, has the player defeated the boss or collected 1,000 coins? How do we combine these separate true, false answers into one final decision? For that, we need logical operators. Welcome to lesson 2.07. Today, we are mastering the final set of operators which allow us to build complex, intelligent logic. Logical operators do not operate on numbers like 10 or 5. Instead, they operate on the results of comparisons. They work directly with the true 1 and false 0 values. We will cover the 3 essential logical operators: logical and logical or logical not. First, logical and the strict operator. The AND operator is the strict one. It checks if all conditions are true. If even one condition is false, the entire expression becomes false. Think of it as, I need this to be true and that to be true too. True and true equals true. True and false equals false. False and true equals false. False and false equals false. Example: integer score equals 500. Integer hasty equals 1. Integer result equals score is greater than 100 and hasty is equal to 1. Is score greater than 100? Yes, true. Is hasty equal to 1? Yes, true. Because both sides are true, result will be 1 true. Second, logical or the lenient operator. The OR operator is the easygoing one. It checks if at least one condition is true. The only way it can be false is if all conditions are false. Think of it as, I just need this to be true or that to be true. True or true equals true. True or false equals true. False or true equals true. False or false equals false. Example: integer coins equals 50. Integer has VIP pass equals 1. Integer can enter equals coins is greater than 1,000 or has VIP pass is equal to 1. Is coins is greater than 1,000? No, false. Is has VIP pass is equal to 1. Yes, true. Because at least one side is true, can enter will be 1 true. Third, logical not, the inverter. The not operator is the simplest. It doesn't combine two things. It just flips or inverts a single value. Turns true into false and false into true. Not true equals false. Not false equals true. Example. This is extremely useful for checking if something is not true. Integer is game over equals 0. Integer can player move equals not is game over. Is game over is 0, false. Not is game over flips that false to 1, true. So, can player move is true. This is a huge milestone. We have now completed our entire toolkit of operators. We can calculate new data, store that data, ask simple questions, and combine those questions. We have all this logic, but our program is still silent. We can't see the results of our calculations. We can't see the final true, false output. How do we make the program communicate with us and show us the value stored in a variable? We used printf, hello, world. But how do we make it print a variable like score? Click on the next video to finally learn how to output our data in lesson 2.08. Basic data input, output, the printf function, formatted output. We have just completed our entire toolkit of C operators. We can perform complex calculations, we can store values, and we can even make logical decisions that result in a 1 true or a 0 false. But there's a big problem. All of this is happening silently. If you run your program, you see nothing. Your program calculates the result, but it never shows you the answer. How do we make the program communicate with us? How do we print the value of the result variable to the screen? Welcome to lesson 2.08. Today we begin one of the most important topics, input, output, or I/O. We will start with output. You already know the printf function from hello, world, but that just printed a static piece of text. Today we unlock the real power of printf formatted output. This means learning how to print the contents of our variables by using special placeholders called format specifiers. We will master the three most essential specifiers: %d for int, integers; %f for float and double decimals; %c for char characters. First, the problem: how to print a variable. Let's say we have this variable, integer score equals 100. If you write printf score, the program will just print the word score. It won't print the value 100. To print the value inside the variable, we need to tell printf two things: where to put the value, what type of value it is. We do this with a format specifier. Second, the core format specifiers. Number 1, %d for integers. The specifier for an int is %d, which stands for decimal, a base 10 integer. You put %d inside the quotes where you want the number to appear. Then, after the quotes, you add a comma and the name of the variable. Integer score equals 100. Printf, your score is %d score. Output will be, your score is 100. Number 2, %f for decimals. Float, double. To print a decimal, we use %f, which stands for float. Float price equals 19.99. Printf, the price is %f, price. Output will be, the price is 19.990000. Note, printf often adds extra zeros for precision. That's normal. Number 3, %c for characters, char. To print a single character, we use %c for character. char grade equals a. Printf, your final grade is %c grade. Output will be, your final grade is A. Third, combining and the new line character. You can use as many specifiers as you want in a single printf statement, as long as you list the variables in the correct order after the comma. Integer score equals 100. Char grade equals A. Printf, your score is %d and your grade is %c, score, grade. Output will be, your score is 100 and your grade is A. But wait, that's all on one line. How do we add a line break? We use a special escape character, \n. This \n is the universal symbol for a new line. Printf, score, %d\a, score. Printf, grade, %c\n, grade. Output will be, score, 100 new line, grade, A new line. We have now mastered output. Our program can finally talk to us and show us the results of its hard work. But programming is a two-way street. We can talk, but we can't listen. How do we ask the user what is your age? And then let them type a number, and then store their answer in an integer variable. This is input. And for that, we need the other essential I/O function, scanf. Click on the next video to watch lesson 2.09. Basic data input, output, the scanf, function, user input. In our last lesson, we learned about output. We used printf to make our program talk to us, showing us the values of its variables. But this is still a one-way conversation. The program talks, but it cannot listen. What if we want to build an interactive program? What if we want to ask the user, please enter your age, and then store their answer in an integer variable? To do that, we need the other half of I/O. We need input. Welcome to lesson 2.09. Today, we are learning the scanf function, the C language's built-in way to read formatted input from the user, usually the keyboard. This function is the direct opposite of printf. Printf prints a variable's value to the screen. Scanf scans a value from the keyboard and puts it into a variable. To use scanf correctly, you need two things: a format specifier, like %d, %f, %c, just like printf. The addressive operator, which is the most critical and most forgotten part of scanf. First, how to use scanf. With %d integers, let's build an interactive program that asks for an age. First, we need an empty box to store the answer. So, we declare a variable, integer user age. Next, it's good practice to prompt the user so they know what to do. Printf, please enter your age. Now we use scanf to listen for their input and store it. Scanf, %d, address of user age. Finally, let's print it back out to prove it worked. Printf, you are %d years old. \n, user age. Second, the most important part, the addressive operator. What is that ampersand? And why is it there? This is the single biggest point of confusion for scanf. Here's the difference. Printf, user age, only needs the value of the variable to display on the screen. Scanf needs to change the variable. It needs to know the memory address of the user age variable so it can go to that address and drop in the new value. The addressive operator means get the address of. So, scanf, %d, address of user age, is telling the program, listen for an integer, and store it at the memory address of the user age variable. If you forget the ampersand, your program will crash. This is the number one mistake. Third, using scanf with %f and %c. The logic is the same for other data types. Just use the correct specifier. For float, scanf, %f, ampersand price. For char, scanf, space %c, ampersand grade. Note the space. Fourth, the critical scanf, trap with %c. Wait, why did I put a space before the %c? Scanf, space %c, ampersand grade. This is the second biggest trap. When you type an age, like 25, and hit enter, two things go into the input buffer. The number 25 and the new line character, \n, from the enter key. The scanf, %d, reads the 25, but leaves the \n behind. If your next command is scanf, %c, it will immediately read that leftover \n as the character and won't even wait for you to type a grade. The space in scanf, space %c, is a magic instruction. It tells scanf, please skip the new line and then wait for the real character. Rule: always put a leading space before %c when using scanf. This is a huge milestone. We have now completed all the fundamental concepts in Section 2. You now have all the tools you need to build real, simple programs. Variables and data types: integer, float, char, constants, const, #define, operators, arithmetic, assignment, comparison, logical, and now I/O, printf, and scanf. You can now calculate, make decisions, and interact with the user. The only thing left is to practice. You don't become a programmer by watching. You become one by doing. Click on the next video to start Lesson 2.10. Exercises to practice programming thinking skills. No answers. Try to solve them on your own and then, and only then, move on to Lesson 2.11, where we will solve them together. We have just completed Section 2, Fundamental Concepts. This is a massive milestone. After learning the lessons in the section, you know how to create variables, integer, float, char. You know how to create constants, const, #define. You know how to use all the operators, arithmetic, assignment, comparison, and logical. And you know how to interact with the user, printf, and scanf. You have all the tools. But I have to be honest with you. Up to this point, you have only been watching. You haven't done the most important part of programming: problem solving. This video is where that changes. Welcome to Lesson 2.10. This video is different. This isn't a lesson. It's a challenge. I am about to give you a series of exercises designed to test the knowledge we learned in Section 2. Here are the rules. I will present a problem. You will pause the video and go write the code. Open your editor, try to solve it, and struggle with it. That struggle is the learning process. There are no answers in this video. The answers are in the next video, 2.11. Do not click on the next video until you have seriously tried to solve these problems. You will learn nothing by just watching the answers. Are you ready? Let's begin. Exercise 1. The rectangle calculator. Topics: variables, arithmetic, printf. Create a C program. Inside main, Declare two integer variables named length and width. Initialize length to the value 25 and width to the value 15. Create a third integer variable named area. Calculate the area of the rectangle length * width and store the result in the area variable. Finally, use printf to print the result in a clear format, like the area of a 25 by 15 rectangle is area. Pause the video now and go do it. Exercise 2, Interactive Circle Calculator. Topics: scanf, float, const, printf. Create a program that calculates the circumference of a circle. Define a const for pi. Use 3.14159. Declare a float variable named radius. Use printf to ask the user, please enter the radius of the circle. Use scanf to read their input and store it in the radius variable. Calculate the circumference, 2 times pi times radius, and store it in a float variable named circumference. Print the result, like, the circumference of your circle is circumference. Pause the video and go try this one. Exercise 3, Even or odd. The logic test. Topics: scanf, percent modulus, is equal to operator comparison. This is a logic test. Ask the user to enter one whole number, integer. Use scanf to read their number. Now, we want to know if it's even or odd. Remember the modulus operator, %. Create an integer variable named is even. Your goal is to have this variable store 1 true if the number is even, or 0 false if it's odd. Hint: use the modulus operator, then use the comparison operator is equal to check if the remainder is 0. Finally, print the result like this. Is the number even? 1 equals yes. 0 equals no. Is even. Pause and try it. This one tests your operator knowledge. Exercise 4, Temperature Converter. Topics: scanf, float, arithmetic, integer versus float division. Create a program that converts Celsius to Fahrenheit. Ask the user to enter a temperature in Celsius. This should be a float. Read their input using scanf. The formula is Fahrenheit equals Celsius times 9/5 plus 32. Warning: the trap if you just write 9/5, C will perform integer division. 9/5 equals 1. To fix this, you must use floating point numbers. Write the formula as Celsius times 9.0/5.0 plus 32. Store the result in a float variable named Fahrenheit. Print the result. Pause the video and complete this challenge. Exercise 5, Leap Year Checker, Logical Operators. Topics: scanf, modulus, and or. Create a program that determines if a year entered by the user is a leap year. Ask the user to enter a year, integer. The leap year rule. A year is a leap year if it is divisible by 400 or it is divisible by 4 and not divisible by 100. Create an integer variable named is leap year. Write a single compound expression using the modulus comparison is equal to, is not equal to, and logical and or operators that stores 1 true if the year is a leap year or 0 false otherwise. Print the result like, is the year you're a leap year? 1 equals yes. 0 equals no. Is leap year. This is a complex logic puzzle. Pause and take your time. Exercise 6. The Ultimate Operator Challenge. No extra variable. Topics: advanced arithmetic, assignment operators. Warning: this is the most difficult problem in this section. Initialize two integer variables, int a equals 5 and int b equals 6. Your task is to swap the values of these two variables so that it becomes 6 and b becomes 5. The rule: you must not create any additional variables. No temporary temp variable. You must solve this using only arithmetic and assignment operators. Plus, minus, assignment, plus equals, minus equals, etc. in a series of 3 statements. Finally, use printf to print the new values of a and b. Pause the video now. If you solve this without cheating, you have a good programming mind. How did you do? Was it harder than you thought? Did that leap year logic tie your brain in knots? And did you solve the ultimate swapping challenge? If you are frustrated, good. That feeling of frustration, and then the click when you find the solution, that is programming. Please, I am serious. Do not click the next video until you have tried. If you just watch my solutions, you are robbing yourself of the learning experience. When you are ready, and only when you are ready, click on the next video, Lesson 02.11, to see how I solve all 6 of these exercises step by step. Welcome to the solution video for Section 2 exercises. Before we start, I need to be absolutely sure. Did you genuinely struggle and attempt to solve all 6 problems from Lesson 02.10? If you didn't, please go back. Close this video right now. The true learning happens in the struggle, not in watching me show the answers. If you tried your best, failed a few times, and are now ready to check your logic, then let's begin. In this video, we will solve all 6 exercises step by step, reviewing the core concepts from Section 2 along the way: variables, data types, and constants, arithmetic, comparison, and logical operators, input, output, printf, and scanf. Open your code editor and compare your solutions with mine. Solutions. First, Exercise 1, the rectangle calculator. Topics: variables, arithmetic, printf. Solution logic. This was the warm-up. It simply tested variable declaration, initialization, the multiplication operator, and basic formatted output, %d. Variable declaration and initialization. Use arithmetic operator multiplication and assign the result. Use printf with the %d format specifier. Key takeaway: always declare the variable type, integer, before its name, and remember the order of variables in the printf list must match the order of the %d specifiers. Second, Exercise 2, interactive circle calculator. Topics: scanf, float, const, printf. Solution logic. This tested 3 concepts: defining a constant, const, using the correct data type for decimals, float, and getting user input with scanf. Declare a constant using const. Prompt the user. Use scanf with the %f format specifier and the addressive operator. Calculate the circumference, 2 times pi times radius. Output result using %f. Key takeaway: don't forget the ampersand before radius in scanf. Third, Exercise 3, even or odd. The logic test. Topics: scanf, %sign modulus, is equal to comparison. Solution logic. This tested your ability to use the modulus operator and combine its result with a comparison operator, is equal to. Core logic. Number mod 2 gives the remainder 0 or 1. The comparison operator is equal to checks if that remainder is 0. If it is, the whole expression evaluates to 1 true. Key takeaway: the modulus operator is the programmer's trick for determining divisibility and parity. Fourth, Exercise 4, Temperature Converter. Topics: scanf, float, arithmetic, integer versus float division. Solution logic. This tested your awareness of the integer division trap. Simply typing 9/5 would result in 1, because C discards the decimal. You must force C to use floating point division. The key is using 9.0 and 5.0 float literals to force float division. Key takeaway. In C, when two integers are divided, the result is an integer. To get a decimal result, at least one of the numbers must be a float, e.g., 9.0 or 5.0. Fifth, Exercise 5. Leap year checker, logical operators. Topics: scanf, modulus, and or solution logic. This was the most challenging logic puzzle, requiring the correct nesting of logical and illogical or to implement the complex rule. The leap year formula combined logic using operators. Year mod 400 is equal to 0, or year mod 4 is equal to 0, and year mod 100 is not equal to 0. Key takeaway: parentheses are crucial for ensuring the and condition is evaluated correctly before the outer or condition. Sixth, Exercise 6. The ultimate operator challenge, no extra variable. Topics: advanced arithmetic, assignment operators, solution logic. This required creative use of assignment and arithmetic to temporarily store the sum and then subtract to isolate the values. The three-step swap. First, store the sum of A and B into A. A is now 11. Second, subtract B from the new A to get the original A, 5. B is now 5. Third, subtract the new B, which is 5, from the total sum A, which is 11, to get the original B, 6. A is now 6. Key takeaway. This mathematical trick shows how powerful and sometimes cryptic using only operators can be. In real-world coding, you would usually use a temporary variable for clarity, but this exercise proves your understanding of memory manipulation. Congratulations! If you managed to solve all of these, you know how to use and apply the knowledge of this section, fundamental concepts, to the problems. We have all the basic building blocks. Now it's time to put them to work. Right now, your program only makes a single decision and runs one path. It needs the ability to truly control its flow, to run code if a condition is met, and to run code multiple times, looping. That's the focus of our next section. Click on the next video to begin Section 3, Control Structures, starting with Lesson 3.01, Conditional Statements. If, else.